Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Welcome back. Problem 7.103. A basketball has 300 mm outer diameter and 3 mm wall thickness. Determine the normal stress in the wall when the basketball is inflated to 120 kilopascal gauge pressure. So let's start with the given data. In given data, it is given as this is a basketball. So you know that basketball is spherical in shape. Clear? The outer diameter d naught is given as 300 mm, which is again equal to 0.3 meter. Thickness of this wall is 3 mm, and that is equal to 0.003 meter. And internal pressure P is equal to 120 kilopascal, which is equal to 120 into 10 raised to power 3 pascal. Clear? What we have to find is normal stress in the wall. So we will find the normal stress. Solution. As we know that for spherical shape, we have normal stress in spherical ball is equal to sigma 1 is equal to sigma 2, which is equal to P into R divided by 2T. Clear? So here we have P, we have T, but we do not have R. So R is equal to 1 over 2 d naught minus T. Clear? So 1 over 2 d naught is 0.3 meter and minus T is 0.003. So when you calculate it, you will get this T is equal to 147 into 10 raised to power minus 3 meter, or you can say 0.147 meter. Clear? Now you have R, you can put in this formula. Sigma is equal to P into R divided by 2T. So P is given as 120 into 10 raised to power 3 pascal. R is 0.147 clear meter, and T2 into thickness is 0.003 meter. When you calculate it, it will be 2.94 into 10 raised to power 6 pascal. Or you can say that sigma normal stress is equal to 2.94 mega pascal. So this is the answer of question number 7-103. I hope you have enjoyed. Thank you.